Hi, Assalamualaikum. Welcome to Wave and Vibration class. For this video, we discuss of the mesh spring system for simple harmonic motion. This is part of the chapter 1. So what is a mesh spring system? Of course, they have two components, which is spring and also mesh. And for this simple harmonic motion, we will measure the frequency of the oscillation mesh spring system. So we can measure the period of this oscillation. From the period, we can find the frequency. And later on, we can discuss on the how to prove it the equation using the mathematical method. So let's go. So imagine that we have the mesh spring system in the horizontal. Why horizontal? Because we want to avoid the acceleration to become the gravity because it's constant. So right now, it become the horizontal. So you can imagine that the mesh spring system, and on top of the table, we have the roller here, so that we can avoid to measure the friction. So this mesh spring system will oscillate to the right and the left. Okay, with the oscillation will be x, and the amplitude will be the x naught. Okay. So this happen for the mesh spring system. So we have two theories to calculate for the mesh spring system, which is Hooke's law, okay, and also the Newton's law. And for Hooke's law is equal to minus kx, okay, and for the Newton's law, if equal to ma, okay, the acceleration times the mass. And from here we have the ma is equal to minus kx. Okay, right now we neglect the friction, and we imagine that the mesh spring system will oscillate. So the x itself is equal to amplitude, which is x naught cos omega t. So from here, what we try to find is the frequency, or we call it as a angular frequency. Okay, so it's similar to the frequency, just is have the 2 pi times the f. So to have this calculation, okay, so we know that the acceleration, okay, acceleration itself is equal to d over v, okay, dv over dt, okay, dv, which is v is the velocity, and we know that velocity is equal to dx over dt, differentiate of the displacement over the time. So we know that from here we have the acceleration is equal to d square v over d square x over dt square, okay, double extension of the x. So for this equation, so we can continue to rearrange, okay, divide everything with m. We have here d square x over dt square equal to minus k over m x. So we can bring everything to the left. So we have here d square x plus km x equal to 0. And to solve this, our target now is to find the equation for the omega. So we have dx over dt, means that because we define x is equal to x naught cos omega t, because x is not a static, it's a moving, okay, oscillate. So x will oscillate from the cos omega t, something like this, okay, t and x. So here is a 2 pi, and this is pi, okay, pi over 2, 90 degree, 180 degree, okay, 360 degree. So the maximum one will be here x naught, the amplitude. Okay, so because the mesh spring system will oscillate something like this, okay, oscillate up and down, something like a wave. So when differentiate x naught cos omega t, when we differentiate cos omega t, okay, because x naught is a constant, okay, x naught is a constant, differentiate cos omega t, we have a minus, okay, minus sine omega t, and then we differentiate in the inside, so we have here, bring here omega. And for the double differentiation, we differentiate sine omega t, okay, So differentiate sine omega t, we have again cos omega t. So we have here x naught cos omega t, and differentiate again, omega will bring front, so we have omega square because we have omega here. So to make it simpler, okay, we have here x naught cos omega t, okay, here x naught cos omega t. So x naught omega is equal to x. So we have here for double differentiation, or the acceleration is minus omega square x. And then we put everything in this equation. So when we put in the equation, d square x over dt square is equal to minus omega square x, and then we plus k over m, we maintain the x equal to 0. Okay, we bring this to the right and we rearrange, we come omega square x equal to k over m x. So here, because x same here, we can cancel, and from this we get the omega square is equal to k over m, or omega is equal to square root k over m. So from the equation of motion, we have here d square x over dt square for mass spring system plus omega square x equal to 0. So this will be the main equation. Okay. So now we know that omega is equal to k over m, square root k over m, and we know that omega is equal to f, 2 pi f. And we know that frequency is equal to 1 over t, which is period. So we have 2 pi over t. Okay, so we can convert everything to the something meaningful for us to calculate. So for frequency, we have here frequency is equal to 1 over 2 pi square root k over m. Okay, since that omega is equal to 2 pi, so 2 pi will bring here. And for the period, of course, the invert of the frequency, we have here 2 pi square root m over k. So when we have mass spring system with Fm, okay, when we increase the mass 2m, so the period will increase. Mass increase, the period will increase. Means that the time or the period needed for this spring to complete one cycle, okay, to complete one cycle increase. Okay, maybe for first they take 1 second, but the second one maybe they take 2 seconds. Okay, period for the double mass. So when the period increase, means that it take a longer time to complete one cycle, so the frequency will reduce. Okay, because the frequency, the how many cycle they needed for the 1 second. Okay. So this is for mass spring system, and later on we can continue for the pendulum. Okay, so see you for the next video.